Hi guys, I'm going to talk you through the answers to these homework questions on series and parallel circuits, so hopefully you can see what I'm doing here. So first question, 141, draw a diagram to show how the 1.5 volt cells should be connected together to give a potential difference of 4.5 volts. Use the correct circuit symbol for the cell. So circuit symbol for a cell is a long line and a short line, okay? Each one is 1.5 volts. If you want 4.5, you need 3 cells, okay? All joined together like this. Then it says the student built the diagram circuit in the diagram below. Calculate the total resistance of the circuit in the diagram. The total current is 1.6 amps. The voltage is 12 volts, and then the resistance of this resistor is 3.5 ohms. So you want to work out the total resistance. That's potential difference divided by current. So the total potential difference is 12 and the current is 1.6. So the total resistance here would be 7.5 ohms. Okay, the resistance 3.5 here makes up part of the 7.5, but not all of it because you have this other resistor here. So the next part of the question says the resistance of P is 3.5 ohms. Calculate the resistance of Q. So the total resistance is 7.5, and that will be made up of the 3.5 ohms and then this value here, RQ. So if we want to work out what RQ is, you do 7.5, take away 3.5, which is 4. Okay. Then the next question says the student connects 2 resistors in the diagram above in parallel. What happens to the total resistance of the circuit? And you need to be talking here about the resistance decreasing. So when the resistance decreases, it's because you have now got this parallel circuit. There is more than one way for the current to flow. So although you have the high potential, you have a high potential difference, so you've got 12 volts, the current, okay, can now flow through more than one part of the circuit, which means that the resistance is less. So I've written an answer here, but I don't want to write it. What I want to say is there's more than one pathway for the current to flow. Okay, so there's more than one pathway for the current to flow, and so the resistance gets smaller. Now, part 2 says a student set up the electrical circuit shown in the figure below. So you've got 12 volts, an ammeter, a resistor, a 60 ohm resistor, and a 45 ohm resistor. So in this circuit, you've got these 3 resistors that are sharing their 12 volt power supply. And it says here that the ammeter displays a reading of 0.10 amps. And what we'd like to do here is calculate the potential difference across this 45 ohm resistor. So you're going to use the equation V equals IR, okay? And we want the voltage or potential difference across the 45 ohm resistor. So the current is the same all the way around the circuit. That's 0.10 amps. And then you just want it across this 45 ohm resistor, so you're going to do times 45. And that will give you the answer, obviously, of 4.5 volts, okay? The next part of the question then says, calculate the resistance of the resistor labelled R. So we now have this resistor here. Now, we can't really figure out what it is until we know what the total resistance is. So the way we'd work out the total resistance would be the power supply potential difference, so V over I. And then, so that would be 12 over 0.10, which is 120 ohms. So we know that we've got a total resistance of 120 ohms, and that's made up of 45, 60, and R. So if I do 120 will equal 60 plus 45 plus R, and then so I will do 120, take away 60, take away 45, and that will tell me what R is. And it ends up being 35 ohms. Okay. Last part of the question says, state what happens to the total resistance of the circuit and the current going through the circuit when switch S is closed. If you look at switch S, it's above the 60 ohm resistor. So if you close it, the current, rather than going through the 60 ohm resistor, will just go through the switch because it's an easier route for it to travel through. So what you're doing overall is reducing the resistance in the circuit because you're getting rid of this one. It's no longer there. It is there, but the current would much rather flow through the switch here. So your overall resistance is now less. So it says state what happens to the total resistance. So you would say the resistance decreases and then it says state what happens to the current. So the current increases. I've just realised I've made a mistake in the previous answer. 60 plus 4, 120 minus 60 minus 45 is 15, not 35. Sorry. Okay, right. So the last bit of the question. This is the hardest part. This is the hardest question. Okay, so the picture shows a cooker hob, and there's a simplified circuit diagram showing how the 4 heating elements connect to the main supply. So here they all are. Okay, so basically you can turn them on. That's these switches are what on the knobs on the side of the heating elements. That's what you're doing. You're just switching them on. And it says when all 4 heating elements are on, there is a current of 26 amps. So really high current there. And then it tells you it's got a 230 volt main supply. So let's have a look at the questions. Calculate the resistance of one heating element when the hob is switched on at full power. And really important here, give your answer to 2 significant figures. So what we could do with knowing is what the current is in each branch, because we want to look at the resistance of one heating element. So we need to know the current through it. Now there are 4 branches here. 1, 2, 3, 4, and we know that when all 4 add together, they make 26 amps. So to find the current in one, all you do is just do 26 divided by 4, which is 6.5 amps. Okay. We then want to find the resistance across one, so we're going to do R is V over I, and because it's a parallel circuit, each resistor will get the same voltage as the supply, so 230 volts. So it's 230 over 6.5 will give us the resistance. This is the answer that's 35. Okay, so I was looking at the wrong answer. So 35 there. Then it says the table gives the maximum current that can safely pass through copper wires of different cross-sectional area. So basically, the thicker the wire, you can put more current through it. That's what this is saying. It says power sockets in the home were wired using the 2.5 millimeter cross-sectional area. And most electrical appliances are connected to the mains electricity supply. It would not be safe to connect the electric cooker to the main supply by plugging it into a standard power socket. Why? Well, we know it's drawing, the cooker current is 26 amps. And this table tells us that the maximum current of a plug, a normal plug, is 20 amps. So if we plugged it in, the current would be too high. So basically it would trip your circuit straight away, or if it wasn't adequate safety, then it would probably set it on fire. So that wouldn't be great. Okay, so how would you describe that? You're just going to say that the current of the cooker exceeds the maximum safe current. And that's all you have to say for that. And the last part of the question, this part of the question we actually study in the next chapter, but we can talk about it now anyway, because you've probably heard of it. Mains electricity is an alternating current supply. Batteries supply direct current. What's the difference between alternating current and direct current? So AC, alternating current, the current goes in 2 directions, so it moves forwards and backwards, okay? So the current changes direction. And then in DC, that's called direct current. So that comes from like a battery, and that means the current flows in one direction. Okay, so we will look at that in chapter 5 anyway, but that's the answer to that. So have a go at all the questions again, make sure you understand them, and anything you're still not sure about, if you let me know, we can go through it. Okay, thank you.